So for us, the work done by a force F moving an object from A to B can be calculated as work equals magnitude F times magnitude from A to B times the cosine of that angle between them. So let's talk about these things here, okay? This is going to be your force. Force can be considered magnitude. Okay. A to B is the distance on which the constant force is applied.
Just A.
What's that?
That's just A, or is that A and B?
From A to B. And this is the angle between the two vectors.
The distance on which constant force is applied.
So this is going to be point A, this is going to be point B, and this is going to be 130 feet. Okay? And let's say that we have this box. Here's our box here. I mean, what else would you want to do but pull a box across the floor 130 feet, right? I mean, right? Every Saturday we do this. So we're going to pull this box 130 feet from point A to point B. And we're going to pull on a rope that is connected from the bottom. That makes an angle of 25 degrees with the ground. All right, so that's the angle that we're talking about. And we're going to pull with a constant force of 30 pounds. So 30 pounds, lbs. So we're applying 30 pounds of force at an angle of 25 degrees for a distance of 130 feet. Let's calculate the work required to make this happen. What is this? No, thank you very much. Okay. Don't know what happens there.
Is a box 30 pounds, or is...
No. We're applying 30 pounds of force to the box. So we're pulling with 30 pounds of force. Okay?
Do you have to know how much a box would be?
Nope. Not in this case. Because we're not calculating that. We know how much we're pulling.
So 30.
Mm-hmm. So for us, the work done. So the work is going to be the force vector times AB times the cosine of theta. Okay, the force vector is 30 pounds. We're pulling with 30 pounds of force. We have a distance vector of 130 feet.
Wait, how's 30 a vector when the b scale?
No, it's a force vector. It's a force, the magnitude.
Okay.
30 pounds of force. Okay? Because vectors are representative of forces, right? So cosine of 25 degrees. So all we gotta do is we gotta run this through our calculator. What mode should we be in, guys? We should be in degrees. How come? Because we're trying to take a degree. Absolutely. All right.
If you're trying to get an answer that's a number, and you're not necessarily finding a degree.
There we go. 3,534. So now, hey, what do we measure this in? Okay, this is going to be measured in foot-pounds of work. Foot-pounds of work. So that's a considerable amount of work, okay? Yeah, or Newton meters, right? Whichever one we're doing. Okay. Here we go. We'll give you a you try here.
Are you on 3?
Yeah, I think so, right?
No, we're on 2.
Oh, we're on 2. Thanks.
How many boxes?
There's only 3. All right. Okay, ladies and gentlemen, here's the setup. You are pulling a wagon 100 feet across the floor. You are applying 25 pounds of force at the handle of the wagon. The handle makes an angle of 38 degrees with the horizon. Calculate the amount of work required to pull a wagon 100 feet with a constant force of 25 pounds being applied to the handle at 38 degrees to the horizon.
Why is it not?
Do you get about 1,970 foot-pounds for dragging a wagon across the floor? Okay, here we go. Last idea.
So what was the answer? Did you go back up really quick? W equals
1,000.
1,970, around that. Okay, last one here. Check this out. Here we go. So there is a ramp. Okay, and the ramp is 60 feet long. So from here to here is 60 feet. The ramp makes an angle to the ground of 11 degrees. This might be a little bit more than 11 degrees. 11 degrees, okay? We're pulling a box up a ramp. Okay? And we're pulling a box. If this is the horizon, and we're pulling with an extra 35-degree angle here. Okay? All right, relax. All right. Okay. So we're pulling a box up a hill, and right, because that's what our favorite thing to do, pull a box up a hill. And we have an 11-degree hill that we're working with, but then we're pulling the handle 35 degrees from the horizon. Okay.
He is IKEA the musical.
What you guys are saying? Okay. So if I put these together, all right. So let's see here. If this angle here, if this is my 35-degree angle, this one here, right? I pull it out, and then I also have 11 degrees that creeps into that angle right there. What's the leftover part? It's the 35 minus 11 degrees.
Wait, how do you just automatically insert 11 there?
And then
Well, because this angle here, do you see this angle here?
Yeah.
It's the same as inserting it right there.
do you just shift the coordinate plane?
Is that some kind of geometry thing?
Okay, so is everybody on board with now why it's 35 minus 11?
Yes.
Okay, good. So we're applying a force, this part here on the rope that we're pulling, we're applying a force of 50 foot-pounds. All right? So for us, the work done is going to be 50 times the distance we're doing is 60 degrees times the cosine of the subtraction of the two angles, which would be, what, 24? 24 degrees. So the work required to pull this box with a constant force of 50 foot-pounds applied to the rope or the handle up an 11-degree angle at 35 degrees to the horizon would be about 2,740 foot-pounds.